Okay, so we have one more problem that we can do, and I didn't think we had enough room on the other video to do it. So we're just going to do this last problem. So it says similarity is the key to solving all cup problems. Try one now with just the basic dimensions of the cup given. So they're only showing you the cup, not the extended cone that would result, right? So remember up here, they did this part of it. Well, that's what we're going to do. They're telling you that from here to here, from here to here, of the larger diameter is 8 and the smaller diameter is 5.6. Well, remember, when we find cones, I need the radius, not the diameter. And the radius is just, a diameter is just 2 times the radius. So there's 2 radii in the diameter. So basically, I'm just going to cut these 2 pieces in half. So the radius up here is equal to 4 centimeters, and the radius down here is equal to 2.8 centimeters. So if I draw this picture again down here, I know this is 4. I know this is 2.8. I know this piece is 15. And this whole piece is 15 plus x. Right? I just took this piece from up here, recopied it so that it had the big cone from that would come down here to someplace, and the smaller cone that would come down here someplace. All right, so we're going to find the volume of the big cone. So the volume of the large cone is equal to, remember, the volume of a cone is equal to 1/3 pi r squared h. R is the radius, h is the height, pi is pi. So you would, for the large cone, the volume, so it's 1/3 times pi times the radius, 4 squared times the height. Oh, I did the wrong thing first. Hold on. Take a step back. We're going to do that in a minute, but I have to find out what h is. I have to find out what x is, so that I can find out what this whole thing is. So remember, I'm going to do my I'm going to do the similarity. So this part I'm going to do first before I do this, because I don't know what the h is and I can't use the x. So what you're going to do is you're going to say the radius of the small to the height of the small cone, or the small triangle, is equal to, or sorry, you're saying the base times the height is equal to the base times the height. So you're going to cross multiply, so you're going to get 4x is equal to 2.8, 15 plus x. I'm going to come up here. So it's 4x is equal to is equal to 2.8x plus 42. You're going to subtract 2.8x from both sides, and you're going to be left with 1.2x is equal to 42. Divide both sides by 1.2. X is going to be equal to 35. So if x is equal to 35, that means the whole one is 15 plus 35, which is going to be 50. Okay, so these are all against centimeters, but we'll use that label when we get to the bottom. But that's what I did there, guys. That x is equal to 35. Okay, so now we're going to come over here. So we know the height is 50, so the height is 50. So we're going to do 4 squared times 50 times pi. Take that whole number and divide by 3. So the volume of the large cone is equal to 837.758 centimeters cubed. Then I'm going to find the volume of the small cone, which is going to be equal to 1/3 times pi times the radius, which is 2.8 squared times the height. Well, the height was x, so the height is 35. We're going to put 2.8 squared times 35 times pi into my calculator and divide that whole thing by 3. So the volume of the small cone is equal to 287.351 centimeters cubed. And then they want you to find the volume of the cup. The volume of the cup is equal to the volume of the large cone minus the volume of the small cone. So when I take this number and subtract this number, I get 287 points. I'm sorry, wrong number. It will be 550.40 centimeters, 7 centimeters cubed. But then they want you to round to the nearest cubic centimeter. That means that they don't want any decimal. So your final answer is 550 centimeters cubed.